Hello, this video is for my NOVA Online Math 161 students, and we are reviewing for our first module exam. And the topic that I want to go over in this video is how to identify domain and range of the relation and determine whether a relation is a function given a set of ordered pairs. So here's the first question, part A. Identify the domain and range. Whoopsies. Hello, this video is for my NOVA Online Math 161 students, and we're reviewing for Module 1 exam. In this video, I am going to talk about how to identify the domain and range of the relation and determine whether the relation is a function given a set of ordered pairs. So here is the first order pair for you. For the first point, I have negative 10, 3. Second point, negative 8, 3. Third point, negative 3, 5. And the last point is negative 7, 3. So I read all those ordered pairs, but if you want to find the domain and range first, we just have to separate the ordered pairs. So let me write the domain first. So here's the domain for this relation. Domain are all the possible x values. So what you want to do is list all the x values before the comma. So I highlighted 4 numbers in these ordered pairs, and those are negative 10, comma, negative 8, negative 3, and negative 7. And I put braces around them to make it a set. Now let's find the range. Range values are all the possible y values of this ordered pairs. So starting with 3, 3 again, 5, and 3. Well, if you noticed, 3 repeated like 3 times, right? So when you write the range for this relation, you do not have to write the 3 times. So here's how I'm going to do this. I'm going to draw the brace and put 3 inside, put a comma, put 5, and I'm going to close the brace. So that's it for the range. Now, the last thing that we have to do is to tell whether this is a function or not. So if you want to see if a relation is a function or not, you need to make sure there is no repeating x values. Do we have 4 different x values? Negative 10, negative 8, negative 3, negative 7. All the numbers in the domain are different. Okay, so yes, this is a function. Yes, it is a function because all x values, no number in the domain is repeating. No x value is paired to two or more different y values. So we're going to say, yes, it is a function. I have another example that we can look at, which is right here. So let's look at this one together. Let's start by finding the domain first. So domain values are all the x values. So let me highlight all the numbers that are before the comma in each of these ordered pairs. So let's write domain. For this set of ordered pairs are, starting with negative 10, negative 8, positive 8, and negative, hold on guys, hold on. I was about to say negative 10, but didn't we have that already in the beginning, right? So guess what? We have a repeating x value this time. So when I write the domain, the numbers for the domain, even though we have 4 ordered pairs, I only listed 3 numbers, okay? Because you do not have to write down the repetition when you write the domain. So later we're going to conclude it is not a function because negative 10 repeated. See? You cannot have repeating x values to be a function, okay? Because what we are looking at is when you plug in negative 10 for the first time, oh, look, the answer came out to be 1. So every time you plug in negative 10, it better come out to be 1. But in the very last one, when you plug in negative 10, it didn't give us 1, but it gave us negative 7. So this relation is broken. It's not going to give us the same output for the same input. So for that reason, we're going to say this is not a function. But hey, hold on. Let's find the range first. If you want to find the range, you just have to list all the y values. So I'm going to highlight those in green, okay? So all these green highlighted numbers are the range of this relation. I want to call this function. This was not a function. So the numbers are 1, 2, 3, -7. And we're going to conclude that this is not a function. And the reason is because we have a repeating x value of -10. So -10, when it repeated in the domain, it made it not a function. So, if you noticed, is it okay to have repeating y values? Okay. Yes, that's okay. A function can have repeating y values. Think about the quadratics. But if it has repeating x values, you need to conclude that it is not a function.